This is Steve Piloff from George Mason University. Let's talk about the future value of annuities. So the future value of annuity is the value at time t. So we have an annuity. So we have a situation where we're making our first contribution to savings in one period. We're going to make t of those contributions every period. So our first one's in time 1, our second's in time 2, our third's in time 3. Second last in t minus 1, our last in t. And the future value of that annuity is how much money we have in our account, what the future value is as of time t. So it's important that you got a t period annuity that the cash flows for t periods, and we talk about the future value, it's as of time t. And so you can see it's just going to be, that first contribution C times 1 plus R to the t minus 1 plus C times 1 plus R to the t minus 2 all the way up to the very last payment, which goes in, and then you say, can I have my money? So it doesn't have a chance to compound at all. So here's the equation. It's just how much would you have in t periods? You would just have the sum of all those future values, what I put in 1 period, 2, 3, 4, all the way up to t, and then the contribution in 1 period times 1 plus r to the t minus 1, in 2 periods times 1 plus r to the t minus 2, all the way up to the last one. You just add those up, and that is the future value of an annuity. I'm about to show you a complicated, simple equation. We're not going to work with that really, but we are going to use the financial calculator, but the financial calculator is going to do this work for us. So we're going to try and solve for the future value, and we're going to tell it all the cash flows, and we're going to tell it the interest rate. So if we tell it the payment, that's the amount of these regular contributions. If we tell it n, that is the number of these. And if we tell it end mode, it says, aha, first one in 1 period, second in 2, third in 3, because end mode tells it the first one's in 1 period. And the nth will be in n periods. I%'s the rate at which these things all compound. PV. If you tell it PV, it has that as an extra contribution at time 0, or much more commonly, an amount of money that's already in the account. And you're going to want to put the payments are going to be negative because you're putting money into an account. And PV, even if it's money that's already in the account, it's going to have a negative sign. You can think that the value of money that's already in my account is positive, and so PV, because it's so funky, is going to be the opposite of that. Another way to think about it is that the more money I have here, the more money I'll have out here, and the more money I put in, the more I'll have here. So we want the sign on PV and PMT to be the same because they're both working in the same direction. And then you go ahead and solve for FE, and it will tell you the future value of all of these cash flows at this point in time, compounded by I%. So let's take a look at an example. Lucky Lottery will pay out 4 equal annual installments of $7,000 with the first in 1 year. And if the annual return is 12.2%, then how much money would the winner have in 4 years if payments are placed in a trust? So the first 7,000 goes in 1 year. There's 4, so 2, 3, 4. And so there's 4 payments, and we want to know how much we'll have in 4 years. So this is a classic future value of an annuity problem. We don't have to use any fancy tools. We can just see it's 7,000 times 1 times 1.122 to the third plus 7,000 times 1.122 squared plus 7,000 times 1.122 plus 7,000. That last one we'll get in 4 years. We take it to the bank and say, here you go, now can I have all my money? And that's what we would get. So we can see 7,000 invested for 3 years would compound to 98.87. 7,000 for 2 years is 88.12. 7,000 for 1 year, 78.54. And the last 7 is 7. And how much would we have when we showed up in 4 years? $33,553. Now, you can do it this way, or you can recognize that this is an annuity, and we want the future value of that annuity because it'll give us the future value time n when we have n payments. So n equals 4. That means there's 4 payments that start in one period. They're negative 7,000. We're putting 7,000 into our account. We're earning 12.2. We solve for FV, get 33,553, and because n is 4, that's when it's giving us the FV4. And that's how much we would have in our trust in 4 years, which is the answer to the question.